solution is a, that solution we are going to utilize for the next solution for second stage. This solution we are going to use for our next solution. Okay, this we call as optimal differential. Then what my point is, what, how exactly we are going to do, how much complexity you are going to reduce this again you are going to get the complexity is big of and cube. Generally matrix multiplication is big of and cube, you know about it. But here, if there is more than one matrices, what? See, one more point. What is there in this? Many matrices are there. I can multiply easily. No, it is not possible. Matrix multiplication at a time you can do only two matrices. But if there is more than two, which two you have to multiply first, then which two you have to multiply next? That is a question. That's a problem. Okay, are you clear my point? And here, how you are going to calculate the question, the problem, this is the best way, this is the worst way. All in that, there we have in matrix multiplication, there we are going to do only two operations. One is additions and multiplications. We are going to ignore this additions. Additions complexity is very less comparatively multiplications. I'm going to I'm going to calculate how many multiplication needed by this way and how many multiplication we needed for this second way, how many multiplication we needed for this third way. Among these three ways, which is the best way, best one that we are going to select. Are you clear? That means we are going to calculate how many multiplications required for each version, each option. Are you clear? For this case, now previously I explained what is Neve method, how we are going to parasize, what is the complexity, everything we have done. Even for this matrix multiplication by using DP, dynamic programming, also I already explained. But once again, I'm going to do that. One point is very, very clear while you are explaining, while you are doing matrix, dynamic, implementing dynamic programming, in the sense you have to create or generate dynamic programming recurrence relations. This is very, very, very important. Without recurrence relation, if I'm doing this, if there is elements are very less, you can do it. But if I given the same logic, I'm going to apply for thousands of elements, lakhs of elements. It is not possible with your high prediction. This point you please remember. That's why compulsory you have to develop one dynamic recurrence relation. Okay, what is the recurrence relation here? Now, how many matrices are there? N matrices are there. What I'm doing here, I'm calculating multiplications. How many matrices are 1 to n matrix? For total multiplications needed to multiply a1 to an matrices. Okay, it is nothing but minimum of let us take here multiplication needed. I divided up to here. This part is 1 and this part is 1. Even one more point you please remember, in dynamic programming we are dividing problem into subproblems. We are doing solution for subproblem. This subproblem solution we are going to use for the next subproblem. This subproblem solution we are going to use for the next subproblem. This problem we are going to use for next subproblem. But in case of divide and conquer, we are adding all subproblems solutions. But in dynamic programming, we are going to form a sequence of decisions. To develop a sequence of decisions, we are going to use the previous solution. Okay. Now here I'm dividing this problem into a1 to k, ak plus 1 to n. Okay. How many multiplications are there from a1 to k? That I'm writing number of multiplications 1 to k. Are you clear? Plus m multiplication required for k plus 1 to n. Are you clear? Plus then while you are multiplying any two matrices, what I told you here earlier, if this is p into q and if this is q into r, this total multiplications is nothing but p q r. I already told you this. This is nothing but the same. Here, if my lowest one is starting with I, this highest one I'm starting with j. Let us take, if I take this as this here, this is I, m, I to n. N is j. Let us take I to j is equal minimum of m, I to k, and k plus 1 to j. J is a final one, upper side. Then here, now this is nothing but this you have to use. That is p of I minus 1, p of k, p of j. This is lower one, this is upper one, this This is k divisions you have done. Okay, this is a solution. Okay, this is a recurrent solution. Now you require to calculate this. Again, you have to apply the same logic. You require to calculate this. Again, you have to apply the same logic. That means this we call as recurrent relation. This we call as dynamic recurrent relation. This is the this is we noted as a dynamic recurrent relation. Okay, are you clear now? Now let us take, I'm going to take one example here. Yesterday I already explained this equation also. This is, what is this? You have this question. This is nothing but if I multiply two matrices, what exactly you may take size of P and Q for A matrix. Let us take this is A matrix. If I multiply this, total number of multiplications is nothing but P into Q into R, P Q R. If you multiply it, you may get the same. Okay. If you do like that, let us take. I'm taking one example here. Here you please, in dynamic programming, you please listen carefully. It is why, because how I'm generating equation, you please remember like that. Don't remember as it is the equation. If you remember as it is the equation, you cannot produce the examination. This is very, very important. But the logic you have to remember. Okay. Now let us take here. This is I taken on A matrix 100 into 10, let us take. B matrix, I take it 10 into 5, let us take. I take an example. C is equal 5 into 20, let us say. This is my matrix. Now I want to multiply this ABC. I want to multiply this ABC. Whether I have to do this ABC, AB first, C last, or A, BC last, like that, then we have two options. Whether you have to do this or this, which gives less number of multiplications, that you have to select. How we know that here only three matrices are there? Visually also we can calculate. If I'm going to AB 100 into 10 into 5 into 6, like that you can do it. But there is more number of matrices, you are able to do it by on your eye prediction. But you have to apply this logic here. Okay, are you clear my point? Are you clear? This for this A, B, C also. What is this now? What happens? This is one matrix. Let us say this is I matrix, and let us say this is J matrix. Now, how I'm going to apply now? What's the secret? M of total number of multiplications is equal one matrix. What is I is equal to first matrix. Then what is the J is equal to third matrix. M of 1 to 3 matrices is equal minimum of M of first K. So what K you have to take? K is nothing but I is less than or equal to K is less than J. This is the formula I already explained to you yesterday. Then I is first I started with K is equal to 1. M of 1 comma 1 plus M of K plus 1, that is 2 comma J. J is 3. Okay. Now plus P of I minus 1. I minus 1 in the sense what? I minus 1 in the sense P of 1 minus 1, 0. P of K, P1. P of J, that P of J, that means P of J is equal to. Are you clear? This is the logical I'm. What is P naught? You know that I already told you. This they are not going to represent like this 100 into 10, 10 into 5, 5 into 20. They may represent this first one is P naught, and these two combinedly we call it as, why? Because 10, 10 is repeated. That's why this is P1, and this we call as P2, and this we call as P3. In your examination also they may give you like this. P naught is this, P1 is this, P2 is this, P3 is this. That is nothing but this one. This 10 two times repeated. This 5 is 2 times repeated. Why? Because the number of columns is equal to number of rows. Then only you can multiply this A and B. Are you clear? Are you clear? This like this they may give you in your examination. Like this you have to apply. You have to apply this. I'll tell you the same example on your this one. Okay. Now you clear. If there is any doubts on this, you can post now. This is the recurrence relation. This is, I'm applying. Once you see here, I'm calculating this value, I'm substituting here. I'm calculating this value, I'm substituting to get this value. That means this is nothing but input of one, output of one solution. I'm going to take it as an input for another solution. That is a logic that we call as optimality principle. For this output, for this m of 1, 2, 3 is equal, I'm substituting output of this m of 1 comma 1, m of 2 comma 3. That means this output I'm taking as input for this output. Okay, that's why this we call as optimality principle. Okay, once problem is obeying optimality principle in the sense, it is nothing but we can apply dynamic programming. Okay, now I'll explain it on numerical example. Now I'll clear this canvas and I'll move to the one numerical example. Also see here. Very simple example I want to explain. Now what I told you here, slide. I'm converting it to slideshow now. Beginning, no, correct. See, try to understand clearly. Very simple example I'm going to explain. See here, how many matrices are there? I taken here. This is A1. A1 is one matrix. A2 is another matrix. A3 is another matrix. Okay. Now, what is the size of my A1? My A1 is 10 to 100. 10 into 100. My A2 is 100 into 5. My A3 is 5 into 5. Okay, clear now? Now, I already told you, this first one we call it as P0. And second one, this and this is same. That's why this is P1 and this P1. This is P2. We call it as P2. And this 5 is same. That's why P2 and P2. And this is P3. Finally, what we may call P0, P1, P2, P3. What is P0? P0 is 10 and P1 is 100. This is 5. This is 50. Okay. In your examination also they may give you this like this. They may give you. They won't give you like this. Okay. Don't. You have to remember like that. Okay. What I'm going to do here? What is my problem? My problem is m of what is I here? How many matrices are there? 3 matrices are there. What is I here? I is equal to 3. What is J here? J is equal. Sorry, I is equal to 1. 1 matrix. J is equal to maximum 3 matrix. Sir, what is the need of this table? You can ask. But there is no need. If you insist, you draw this table. Otherwise, there is no need of drawing this table. Anyway, if you want to fill up this table, also again you have to do this recurrent selection only. There is no a logic to fill up directly this table. Whatever you are calculating here, you are going to fill into this. That's all. How you have to fill up also I will explain later. Then now what is I? I is first matrix. J is the last matrix. What is the K? I will decide later. Now what I have to do now? I have to do here. I have to calculate the number of multiplications. 1, 2, 3. This is my logic. Okay. Now also see here. Now also see here. Listen. Okay. Now also see here. Here this is this m is equal m of 1, 2, 3. I already told you, m of 1, 2, 3. What I'm going to do here, minimum of k is equal to what? K is nothing but I is less than or equal to k is less than j. That means I is lowest size of matrix, lowest matrix, and this is maximum matrices. Okay. Now what is K now? I am taking here for this first one. I am taking K is equal to 1. Two options are there. K is equal to 1. K where is what is I? I is equal to 1. I is less than or equal to K is less than J in the sense J is equal to 3. How many K's you can take? K is equal to 1 you can take, K is equal to 2 you can take, K is equal to 3 you should not take. Why? Because it is less than, not equal to 3. K is 1 is less than or equal to K. That means K is equal to 1 you can take, K is equal to 2 you can take, K is less than 3. That means you should not take 3. That's why for this part I taken as K is equal to 1. K is equal to 1. For this part I taken as K is equal to 3. K is equal, sorry, K is equal to 2. Now if I take K is equal to 1, what happened also see here? M of, what is the formula? Formula is I comma K. I comma K. What is I here? 1. Okay. What is the K here? 1 plus M of K plus 1 comma J. K plus 1 in the sense 1 plus 1. J is equal to 3. Clear? Then P of the J comma, sorry, I comma minus 1. I comma I minus I minus 1 in the sense what is the high here? 1. 1 minus 1 is equal to 0. That's why P0. Okay. What is the K value? PK. PK in the sense what is the K value? P1. That's why P1. What is the P3 value? P3 value is sum. Okay. P3 is the last one. Okay. Are you clear? This is P3 value. This 50 is 50. Okay. Now you got this value. After that, if I take K is equal to 3, K is equal to 2, then K is 3 should not take. Why? Because it is less than 3. That's why M of 1 comma, that means I comma K. I is 1. K is equal to 1. Okay, K is equal to plus M of K plus 1. That means 2 plus 1, 3. Then J. K plus 1 comma J. Are you clear? This is a formula. You want to see this formula. Same formula I am applying. Right? Now, what is the P of K minus 1? Sorry, I minus 1. I minus 1 is what? 1 minus 1 is 0. P0. P of K. That's what P of J. P of J. Okay. Now you clear? Now, if I'm going to do here, I don't know the value of this. M of 2 comma 3. I don't know value of M of 3 comma 3. I don't know value of M of 1 comma 1. I don't know value of M of 1 comma 2. Are you clear? M of 1 comma 1. That means only one element is there. Only one matrix is there. One matrix, there is no multiplication. That's why this we can take it as 0. M of 3 comma 3, this we can take it as 0. M of 2 comma 2, that we can take it as 0. Only one matrix. 2 comma 2 in the sense only one matrix. Okay. Now, if I want to calculate M of 1 comma 2, I have to calculate. M of 2 comma 3, I have to calculate. M of 1 comma 2. Let us see what you require. M of 1 comma 2 required. M of 2 comma 3 required. That's why M of 1 comma 3, 2. That means I is equal to 1. J is equal to 3. Okay. Here, what is the K value? K value varies from 1 to 2. 2 also is not correct. Why? Because it is less than what is the formula? K is less than J. Less than J. It is not equal to J. That's why K you can take it as 1. That's why K is equal to I taken as 1. Now I am applying the same formula. Minimum of M of I comma K. I is equal to 1. K is equal to 1 plus M of K plus 1 comma J. K is equal to 1. 1 plus 1 is 2. 2 comma J. J is equal to 2. And this is P of I minus 1. I is equal to 1. 1 minus 1 is 0. P0. P of 1. P of 1. And P of 2. P of J is equal to 2. Now I am calculating here. I want to see that P of 1 comma 1. I already told you. If these two are same, that is equal to 0. This is equal to 0. M of 2 comma 2. That is equal to 0. Okay. P naught. What is the P naught here? 10. P naught is 10. Okay. What is the P1? P1 is 100. P1 100 I take it here. What is P2? P2 is equal to 5. P2 is equal to 5. 10 into 100 into 5. That is 5000. Make it. That is the value of M of 1 comma 2. Are you clear? That is this value. This. Then come to the what do you require? M of 2 comma 3 also required. M of 2 comma 3 also required. Just you have to apply in recurrent solution. Only nothing is it. Applying recurrent solution. Then what is the I is equal to? I is equal to 2. 2 is less than or equal to K less than, and K varies from 2 to 3 only, not 3 equal to 3. It is K is equal to 2 only. That's why I taken K is equal to 2. I'm substituting here. M of I comma K. I is equal to 2. K is equal to 2. Okay. M of I plus 1 comma K plus 1 comma J. That means K plus 1 is what? 2 plus 1, 3. K is equal to what? 3. M of 3 comma 3. Okay. Now M of 2 comma 2. That means it is single matrix. That's why it is 0. It is M of 3 comma 3. It is single matrix. It is 0. P1, sorry, P of I minus 1. I is what? I is equal to 2. 2 minus 1 is 1. That is P1. Then P of K. K is equal to what you have taken? K is equal to 2. I take it. That's why 2. Then P3, Pj. Pj is equal to P3. Okay. Now what is P1 now? P1 is equal to 100. P1 is equal to 100. What is the P2? P2 is equal to 5. P2 is equal to 5. What is the P3? P3 is equal to 50. Now P2 is equal to 50. Now what you may get? 100 into 5 into 50. Totally 2500 multiplications required. This 2500 I substituted here. Finally, if I calculate this first option, I got 75,000. I got 75,000. In the second option, I got some 7,500. Among these two, how many which is less multiplications? This one is a less multiplications. This is less multiplications. Okay, that's why you have to take this one. What is the answer for this? What I'm going to do? 1 comma 2. That means first I'm going to apply. I'm going to multiply a1 1 comma 2 in the sense a1 into a2. First you have to apply these two first. Then after that m comma 3 comma 3. That means m3 matrix, a3 matrix. After that a3 matrix. This is your answer. Okay, are you clear? Total multiplication is this. Are you clear? How you are going to apply logic of this? Now, what is the need of this table? This table. What is the need of? Okay, anyway, every time you have to calculate this recurrent solution only. What is the need of this table? This table is very simple. Whatever values you are going to get here, I'm going to substitute here. That's all. Finally, it gives this table, it gives a summary for the values. All these values I'm keeping in one table. That is a summary of your results. Okay. Now, how you have to construct a table here? Here we have many ways. In your some books, they may give you, they may construct like this. Don't confuse. They may construct like this. It seems like one interesting table. Nothing is there. The table is like this. Here, any table you can construct like this. How many matrices are there? 3 matrices are there. Just you have to write like this. Just you have to write like this. 3 matrices, 3 divisions you have to take. Okay. You can write here 1, 2, 3. You can write here 1, 2, 3. If I want to construct this way or this way or any way you can construct, no problem. 1 to 1, 1 to 1 matrix, I already told you how much you got? 0. 1 to 1, 0. 2 to 2, what is this? 0. 3 to 3, 0. Okay. He developed like this, no problem. If you draw like this, no problem. If you draw like this, no problem. Okay. Now, what is this 1 to 2? What you got? 1 to 2? 1 to 2 is this one. 5,000. 5,000. 1 to 2, 5,000. He constructed like this. Don't worry, no problem. Then 1 to 2 to 3. 2 to 3 is what? 2 to 3. This one. This value is what? 25,000. You got this now? 25,000. Then M 1 to 3. 1 to 3 is this one. What is this value? Then we have two values. Two values are there. Which is a minimum? Minimum is 7,500. 7,500. Like diamond. everything is a diamond, everything is like this only this table only. Okay, are you clear? Then I'll move to the next question. Next, one more, this one. Okay, first I'll move to this question. Okay, one more example. This is a common example. How many matrices are there here? Nearly 6 matrices are there. It is not simple thing. It is a very difficult thing. 6 matrices are there. How many matrices? A1 is 30 by 35 is the size. What you have to take? P0 into P1. 1. And A2 is 35. This should be same. 35 into 50. That's why P1. They won't give this one. Finally, in your examination, what they may give you, in your examination, they may ask you which is efficient matrices multiplication sequence for P0 is equal to 30, P1 is equal to 15, P2 35, P2 is equal to 15, P3 is equal to 5, P4 is equal to 10, P5 is equal to 20, P6 is equal to 25. Like that they may give you. Sometimes what they may give you like this. P0 to P6 is equal 25, 30, 35, 15, 5, 10 also they give you. You have to understood these are the P0, P1, these are the sizes of the matrices. You should understood like this. They won't give these sizes. Okay. Now this you can understood. You have to understand like this is like this. These are the sizes of the each matrix. Okay. Now here 6 matrices are there. Question is for the 6 matrices A1, A2, A3, A4, A5, A6, 6 matrices. Whether we have to multiply these two first, these two second, these three, these two third. After that, this one, this one. But again, you have to multiply. There is a chance A2, A3 is first. There is a chance A1 is last, A4, A4 like that. Then we have many options you are going to get it. For the six matrices. Many options you will get it. For all these calculating number of multiplication is not simple. That's why simplest way is dynamic programming. Here I'm going to calculate these things by using recurrent installation. Okay, how we are going to do here? See that. I already told you, on diamond also they may construct nothing. Diamond is this one. This is nothing but this matrix. Don't feel this is something like this. How many matrices are there? 6 matrices are there. Six things you have to like 3, 4, 5, 6 like that. And this is 1, 2, 3, 4. This matrix they drawn like this. Don't feel it is different. This and that is same. Okay. Now what exactly here? Now here solution is not solution is already done. That I will explain. Okay. One more example. This is the way of doing this. I'll tell you one more example. This is that example only. I'll tell you. See, don't see this table. This table is after all calculations. You have to fill up this table. Don't draw the table first. Leave that. Okay. Now this is an example. How many matrices are there? 4 matrices are there. A1 is 5 into 4. A2 is 4 into 6. A3 is 6 into 2. A4 is 2 into 7. Okay. Now what is your P0? P0 is equal to 5. P1 is equal to 4. P2 is equal to 6. From this you have to take. It is not separately they won't give. From these you have to select. You have to take like this. This is P0. This 2 is P1. This is 2 is P2. And 2 are the P3. Then P4 is the last one. Okay. Sometimes they will give you this only. You have to feel. You have to take like this. Okay. Now what is the question? Question is you have to multiply A1, A2, A3, A4 matrices. Okay, what is the best method? They are asking, right? That means what? What is the formula? Formula is simple. Very simple formula. M is equal. M of 1 to 4 is equal minimum of what is the K? K varies. 1 is less than or equal to K is less than 4. Then M of I to K plus M of K plus 1 to J plus P of I minus 1, I minus 1, P of K, P of K. That's all. This is the formula. This formula we are going to use. Now I'm using the same thing. But I'll come to the last. From the last, I want to explain some so that you can understand easily what you required is the last one. Actually, what you require, what I given formula, I given M of 1 comma 4. Then what is the K value? K is 1 is less than or equal to K is less than J. K is less than J. No. Then this is equal to, this is the formula. The formula same we are applying. M of 1 comma 4 is equal to minimum of M of 1 comma K plus minimum of K plus 1 comma J. What is J? J is equal to 4 plus P of I minus 1. That is P0, Pk, Pj. Are you clear? This formula I am applying. What is I? I is equal to 1. What is J? J is equal to 4. For this, I am going to take it as K is equal to, what is the K? K varies from 1 is less than or equal to K is less than 4. Now, initially, I'll take K is equal to 1, K is equal to 2, K is equal to 3. Remaining is same. That means what? M of 1, 1 plus M of K is equal to 1. K is equal to 1 in the sense K plus 1, 2. M of 2, 4 plus P of 0, P1, P. If K is equal to 1, then K is equal to, this is the value. K is equal to 3, this is the value. Now, for this, what do you require? You don't know what is this value. What is this value? You don't know. What is this value? That means both are same. That's why it is equal to 0. Both are same. This is equal to 0. Same in the sense only single matrix. This you don't know about it. This you don't know about it. Now you don't know. That's why you have to calculate one by one. This you have to calculate. 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 These values you know about it, but these values you require to take minimum of these. Okay, that's why what I'm going to do here, I'm calculating one by one. Here 1.1, 1.2, 1 comma 2. Then again the formula is same, 1 comma 2. That means what is I? I is equal to 1, K is equal to 2. What is a K? K varies from 1 is less than or equal to K is less than 2. Are you clear? Then if I apply this, M is equal to M of I is equal to 1, K is equal to 1. M of I is K plus 1, that means I plus 1, 1 plus 1, that is 2. Then this is 2. Okay. Now 1, 1, 0, 2, 2, 0. Then P naught, Pk, P2. That means P naught, P1, P2. Means P naught 5, P1 4, P2 is equal to 6. That is 120. Very clear. The table I already told you know how many matrices are there? 4 matrices are there. 4 matrices you have to draw like this. This is 4 matrices. Okay, this is 4 matrices. Okay, here 1 to 1 0. Always directly connect. Or 2 to 2 this is 0. 3 to 3 0. 4 to 4 0. Okay, are you clear now? Then like that. I calculate 1 to 2. This is the value. 1 to 2 is 1 to 3. Then after that, I calculate 2 to 3. 2 to 3 in the sense this one. 2 to 3. And what is 2 value? I is equal to 2, K is equal to 3, and K is equal 2 is less than or equal to K is less than 3. Are you clear? Like that. 3 to 3, 0. 3 to 4, what is the value? You have to calculate now. 3 to 4, what is the 3 to 4? 3 to 4, you got 20, 84. This 84, you have to substitute here. Are you clear my point? And this is like this. Okay. Now only what is the value is there? This value calculate. You have to calculate this value and this value. What is this value? 1 to 3. 1 to 3 calculated. 1 to 3 is what? 88. 88 will come. Then what is the next value? 3 to this one. This value you have to calculate. What is 2 to 4? 2 to 4 they calculate. 2 to 4 is what? 104. 104 they calculate. What is the final value? This value. That is, what is this value? This one. 1 to 4. Final value. This value will give the answer. Finally, if I substitute minimum, you have to take from these three options. You have to take minimum. Minimum how much? 158. 158 you get it. Your answer is what? 158. Okay. Now from this 158, now which is your answer? That is the question. How you got this 158? It's the minimum. Now from these three options are there. Now this is one option, and this is one option, and this is one option. From this, which will give the 158? This is 88. 5 to the 70. 5 to the 10. 10 plus 10 into 7 is 70. 70, 70 plus 88. 158. That means this third one is giving your answer. Remaining all are higher. Third one in the sense what? This one. This one is your answer. This is the third one. What do you mean that M123? That means M123, M123 matrices into M4, M4, this one. Okay, M1. Then how you calculated this to M123? Again, you go back. M123, how you calculated? M123 is 88. Whether this is giving minimum value or this is giving minimum value. What is this? This value is 120 plus 5 into 6, 30 plus 2, 30 into 2, 60. 60 plus 120. That means it is more than this. That's why this is the correct value. Okay. This is your answer. 88 will give on this. That is nothing but the first one. What is the first one? 1 to 1 you have to multiply. 2 to 3 you have to multiply that. That means what? That means what? Here, once you see that, here you may get here 1 to 3, A4 is like this, 1 to 1, M1 to 1, this is M2 to 3. Are you clear? Finally, what happens? This is A1 first, then M2 3. That means A2, A3. Then you go to multiplication of A4. This is your final sequence of multiplications. What is the cost you are going to get it? You are going to get this cost is 158. This is a way of calculating matrix multiplications. Okay. Now, I'm going to like this. You can do many problems. You can do many problems are there. You have to work out on this. Finally, I'm going to calculate the complexity in ego of NQ. By using parameterization, how much you are going to get? You are going to get exponential to the power of 4 to the separated. That means exponential power you are going to get by using parameterization. But I'm not going to use this parameterization. I'm using by using the dynamic programming. I got big of NQ. Okay. Now I'll stop this matrix multiplication. Then I'll move to the next problem. Now, okay, before going to that, what is the next problem? I'll explain with the small example. Okay. Now I explained what is the dynamic programming, what is the optimality principle, how we are going to use this optimality principle into this. Okay. Now I'll share one whiteboard. I'm sharing whiteboard now. I'll explain the next problem. What exactly that problem? I'll explain now. See, this is very important problem. In your working environment also, we are applying the same logic in searching. Actually, you don't know about it. All trees meant for searching. Searching is one biggest operation in your computer science operations. This is very good. Without searching, nothing is there. You have all operation, all things you have to do first searching. Then go to the required stage. For that searching, I'll tell you what exactly this. The next problem is optimized binary search tree. Optimized binary. Try to understand what is the problem. Optimized binary search tree. Binary search tree. Okay. What exactly binary search tree? Knows that binary search tree is nothing but tree. It is nothing but left side is less, right side is more. That you know that. For example, if this is 60 and left side it is equal to 20 and the right side is equal to 8. This we call as BST. Okay. Left side is less than root, right side is more than root. Okay, that is the logic in the BST. I'm not going to discuss BST now. I'm not considering that. Now my question is, what is optimized? Why? What is the need of optimization? Okay, that is the question. For example, if my problem is like this, A, B, C are my elements. Let us take A, B, C are my elements. This A, B, C, if I want to construct BSTs, if I want to construct with these identifiers, I want to construct binary search trees. Then we have many ways. For example, one way is I can construct B is top, A is less than B, and C is more than B. Okay. This is also one binary search tree. And one more binary search tree is C is here, and this is B, and this is A. This is also correct. Why? Because A is less than B, B is less than A. Right side, nothing is there. This is second option. Okay, one more is there. Let us say A is here, and this is B here, and this is C here. This also I can construct. One one can be okay. Now here if I want to construct a binary search tree with these three identifiers, I can construct this way or this way or this way. Why? Because this A is less than B, C is more than D. It is good. Now A is less than B, B is less than C. This is also correct. B is more than A, C is more than B. That's why this is also correct. Then what is the question? The question is, for example, in this option, if I want to calculate, if I want to search an element like A, I require only one down, only one down. And if I want to calculate one search of C within one down in the sense of one height, the height of tree is one. Within one down, if I move down, I can reach this C. Okay. Now that's why this is a way in for this B. For calculation of B between 0, we can calculate. Okay. This is the situation in one. Now come to the second part. If I want to calculate C, there is no problem. You require 0. Then if I calculate B, you require 1. 1 down. If I search A, you require 2 down. How many you require? 3. Summarily, 3 required. But here you require for B it is 0, A it is equal to 1, for C it is equal to 1. Totally you require 2 downs. For these 3 downs. For these 3 downs. Okay. For A it is equal to 0, for B is equal to 1, for C it is equal to 2. Are you clear my point? 2 downs you have to move. Okay, that's why 1 plus 2, 3 downs. Okay, for these elements, 3 required, 3 operations required. For these elements, 3 operations required. For these elements, only 2 operations required. Among these 3, which is the best one? The best one is this one. The best one is this one. How you can decide? You can decide this is the best one. You can say that according to the time taken to set the element. Are you clear my point? Are you clear what problem is there in this? For example, this is for only 3 elements. If there is 4 elements are there, like if else something, I'll explain with an example also. If else something is there, in that case, what happens? I'll explain with an example. Are you clear this point? The what exactly the problem is there here. Okay. Now here see the problem is uh, let us take I'm taking one binary search tree like this. Here then we have A1 is a this is A1 and AN. Let us take A1 is less than A2 is less than to AN. Let us take then P1 or the P1 or the P1 PI and QI are there. P1 PI and QI are there. It is not coming. PI is the probability of element setting. I'll tell you what are the setting elements. QI is the probability of unsearched elements. That means while you are searching, it is you are not getting that element. These are the PI is the probability of this. QI is the probability of this. I'll see. Okay. A1, for example, here I taken simple logic concept that A1 is less than A2 is less than A3. Like that, AN elements are there. AN are identified. So here we're calling it as a identifier. For DS, you are going to say it as a elements. Now with this, what happens? Now I constructed one binary search tree. Let us take this is my binary search tree with consisting of these elements. Now, what I have to do here? What is the question here? Binary search trees we can construct in many ways. Many models are there. Among these models, which gives less time to identify or search the element. That is a best one. That is an optimized one. Okay. Then if there is three, four binary search trees are there with these elements, among these three, four binary search trees, which gives a less amount of time to search an element, that is a optimized binary search tree. That means what? You are going to calculate the time taken to search the element. Okay. The time taken to search the element is depends on what? It depends on two parameters. The first parameter is probability of searching is one parameter, and second parameter is its height. For example, for this you require one height. For this element you require two height. That means what? Its depth, its height or depth. That means probability of that setting element and its depth. It depends on these two parameters. The calculation of the time taken to search the element is depends on probability of setting and the time taken to the depth of the element. Okay, these two parameters we are going to consider or calculate to calculate the time taken to search one element. Okay? You can ask one question, sir, what is the probability? What is the setting probability? For example, I'll tell you an example. Once you see this, this is my element A and this is B, let us take. And let us take this is C. Now I am setting about X. Whether this is X is not here, then X is more than A, I'll go to this side. Then this is, if I see here X is not there, that means there is unsuccess probability also is there. Success probability, for example, if I'm setting for C, it is success. If I'm setting for X, I'll go to this side. Why? Because more than C. More than C, this is this side. This side will give here. I'm not getting result at this level. I'm getting result at this level. Okay. This is unsuccess set probability. This is success set probability. I'm setting about C. I success to set this. That's why my probability is different. This is success set. But if I'm setting about X in the sense, it is not there in this tree, but it is unsuccess set. One point you be clear in setting. There is two probabilities are there. One is success probability and unsuccess probability. This is giving unsuccess probability. This we are representing with ease. Okay, the extended set. We move to more than below this C, and we are checking that whether the element is there or not. It is not there. It is not there in the sense you stop at this place and you will read that it is unsuccess or it is not available. That means what? The probabilities are two types. One is PI is a probability of success. QI is a probability of unsuccess. That's why here I'm going to take PI is a probability of such success. QI is a probability of unsuccess set. Are you clear my point? Are you clear? Now from this what I'm going to do here. I'm going to calculate. I'm thinking about success set voting. Success set voting. How many success sets we require? For example, many elements are there. This is one, and this is two, and these two are the elements. All these success set, that means i's into its depth. It depth. That means its depth. Depth di plus one. Why? Because this level is we call as di is equal to zero. This is zero in the depth. This we call as one depth. Actually, that's why we are calling as di plus one. Okay, are you clear at this point? It is starting with zero. That's why here we call it, this is one, two. Instead of writing like this, if I started with zero, this is, it will become one. But one plus one is nothing but two. Are you clear with point? Then di is a probability. This is the minimize. If you minimize this time, that we call as optimal final state. Are you clear? Sigma of di plus 1. If you minimize this value, that binary search tree will give optimal binary search tree. Are you clear? Optimal binary search tree in the sense we can construct more than 2 or 3 binary search trees with given elements. But among these binary search trees, which gives less time to set the elements, that model is optimal binary search tree. Okay, are you clear what is exactly this problem? Then we have to do the problems on this for the next class onwards. Okay, I'm going to stop at this level.